Alright, today we are going to be writing an essay on the short notes on axo-axonal transmission. We'll work with this outline: an introduction, anatomical arrangement, a sketch, a mechanism of action, the agonist, and the functional significance. So let's begin with an essay. So what is an introduction here? Two key things to take note of. You say that axo-axonal transmission is also called presynaptic inhibition. So if you get to see another essay that says write a short note on presynaptic inhibition, it is pointing towards the same thing, axo-axonal transmission. Now, what else will you want to say? You say it is one of the ways in which the central nervous system inhibits, or the central nervous system does inhibition. All right. So important, we have said, also called ACA, also known as presynaptic inhibition. And we have said that it is one of the ways in which inhibition occurs in the central nervous system. Now, what's the anatomical arrangement for axo-axonal transmission? We are going to have three things there. Number one, we have an inhibitory neuron. All right. Number two, we have an excitatory neuron. And then number three, we have a postsynaptic neuron. All right. So let me show you now in a sketch format. Now, in a sketch format, you will see something like this. That is the number one here. So I call this number one, which is the inhibitory neuron. Then where it empties its information, I'm going to call it number two. So I call this number two. And then where this information should be processed, I'll call that one number three. This should be number three. Now, can we interpret what happens? On number two here, I'm going to show you two receptors. A GABA A receptor, which is coupled to channel called chlorine channel. And then a GABA B receptor, which is coupled to what we call potassium channel. Now, can I explain the story? So in the sketch, you should be able to show three things: an inhibitory, an excitatory, and a postsynaptic. The excitatory should have a GABA A receptor and should have a GABA B receptor. All right. So now let's discuss the mechanism. So what have we discussed so far? Intro, we have said that axo-axonal is also called presynaptic inhibition. And it is one of the ways in which the CNS has or does inhibition. And for anatomical arrangement, we said there were three of them: inhibitory neuron, excitatory neuron, and postsynaptic neuron. For the sketch, you can still see it here still being shown here for you. Now, mechanism, I would want to discuss mechanism, but on the other hand, I want to describe something again about action potential generation. Now, I will label here as minus 90 millivolts, which happens to be resting membrane. Then 75, minus 75 millivolts, which happens to be threshold. And then depolarization occurs here, and we have something like plus 20 years zero. Now, I want to explain something quite necessary. That for any time you want to generate action potential, you must take it from minus 90 and then go up. And this is possible because in a cell, more positives have entered into the cell or more negatives have gone out. Action potential is ever generated when positives enter into the cell or negatives go out. Now, let us see how we can make that with sense here. Now, what are we discussing here? We are discussing the mechanism of axo-axonal transmission. So, number 1 point, we have the release of the neurotransmitter called GABA. So, number 1 point, release of GABA from where? Release of GABA from 1. You know what 1 stands for? 1 stands for inhibitory neurotransmitter. What is number 2 point? This GABA can cause inhibition of our excitatory postsynaptic potential by 2 mechanisms. What and what? Inhibition can be done either by direct mechanism or by indirect mechanism. Good. Now, what is the direct mechanism? The direct mechanism is that GABA will prevent this excitatory postsynaptic potential from ever releasing neurotransmitters. What are examples of neurotransmitters that these can release? So I'll show it here like this. Or let me show you in the actual way it happens. By the way exocytosis occurs. Neurotransmitters like dopamine, neurotransmitters like serotonin, neurotransmitters like acetylcholine. So these are three neurotransmitters that can be released. Now, what have we said? We are saying that number one way in which direct works is by directly inhibiting the release of neurotransmitters. So it just comes and stops their release automatically. And I also want to show you about calcium channel, and I'll explain that again from what we had said before, that for any time we want to ever release neurotransmitters, calcium will need to be influx, and then from there vesicles will bind to membrane, and this will help the release of neurotransmitters. So, but in this case, direct does something, prevents calcium from ever working. Calcium never works, exocytosis will not work, and there will be no release of either the neurotransmitters like dopamine, serotonin, acetylcholine, and what have you. So that's the third point we talk about in direct. Now, for the fourth point in indirect, you would further explain it in two forms. That those that may act on GABA A will do something quite interesting. Now, what do we say? When GABA binds to GABA A here, it will cause the influx of chlorine. Now, if more and more chlorine enters, the chlorine is negative, it's a negative ion. It will make the inside of the cell more negative. And a cell that is more negative from this thing here, you see minus 90 goes down and becomes hyperpolarized, making it difficult to ever generate action potential. And what will happen there is that this cell will not allow for calcium to enter anymore. And no calcium entry will mean that no release of neurotransmitter. So you can run that story again many times, that GABA A will cause chlorine influx. And when it causes chlorine influx, what do you think will happen? There is going to be hyperpolarization. Hyperpolarization, no action potential ever generated. Calcium channels are blocked automatically, and eventually no release of neurotransmitters. Now, what about in GABA B here? In GABA B, something interesting also happens. Once anything neurotransmitter binds to GABA B, there is going to be potassium efflux. So it is going to cause potassium conductance or potassium efflux. If more and more potassium goes out, that means positives are leaving. More positive leaving will leave the inside of the cell more negative. And the negativity inside here still means hyperpolarization, making it also difficult to generate action potential, making it difficult for calcium to influx, making it difficult to release neurotransmitters. So that's the next point to add there. Now, the end result of all of this is that never are we going to have action potential ever going to the postsynaptic. And the postsynaptic will not generate, or will generate, but in a very little amount, what we call a fall in EPSP's value. What's EPSP? Excitatory postsynaptic potential. Are we together? So we have talked about the mechanism. You can run through that story again. That GABA release here can inhibit either by the direct or indirect. For direct, it stops directly, that never are we going to release neurotransmitters. For indirect, it will go through either GABA A receptor or GABA B. For GABA A, chlorine influx, hyperpolarization, blocking calcium channel, never are we going to release neurotransmitters. For the second one here, potassium efflux, we are going to have hyperpolarization, no calcium channel, no release of neurotransmitters. And the end result is going to be that there's going to be a fall in excitatory postsynaptic potential. How about the agonist? The major agonist here for axo-axonal transmission is baclofen. Baclofen is the major agonist. And baclofen has been used for the treatment of spastic paralysis of the spinal cord. Okay, it has also found application in the treatment of conditions like multiple sclerosis. All right. Now, what's the usefulness or the functional significance of axo-axonal transmission. The significance of it is so that the undesired stimuli or undesired reflexes or undesired information are suppressed while desired information are selected. As simple as that. Undesired suppressed, desired are what? Are selected. So with this, we have been able to go through the outline one by one, highlighting important things you must never miss in your next exam. If you have watched to this point and you find this resource quite valuable, kindly leave a comment there. Kindly like, kindly share, and kindly subscribe. And I really do hope that this means a lot to you and for me. Thank you. Wow. So let's go to the next.